I'm going to prove a result that's actually related to my first research project at Utah State, and it's essentially the main idea behind what we did. So we start by considering a family of elliptic curves in Legendre normal form, which I've denoted by x sub lambda. And what we aim to do is count the number of rational points on this family over a finite field. So what we do is we first consider Fermat's little theorem, which states that if p is a prime, a is an integer, and p doesn't divide a, then a to the p minus 1 is equivalent to 1 modulo p. So given that, if I let a be a non-zero element in this finite field, then I know that a to the p minus 1 over 2 is going to be equivalent to 1 if there exists an element y in our finite field such that a is equal to y squared, and negative 1 otherwise. So given this corollary, I actually have this result over here, where if I let a be equal to the right-hand side of my elliptic curve in Legendre normal form, then I know that if a to the p minus 1 over 2 is equivalent to 1, then I have two rational solutions. If it's equivalent to 0, I have one rational solution. And if it's equivalent to negative 1, there are no rational solutions. So in this way, I actually can count the number of rational points on my family of elliptic curves, and it's given by this. So I sum over elements x in my finite field over 1 plus x times x minus 1 times x minus lambda to the p minus 1 over 2. And of course, that's going to be mod p. So this result, this really nice result, is actually what helped me prove my primary result in my first research project at Utah State. My first research project at Utah State dealt with the intersection of algebraic geometry and number theory. And this is something I'm really interested in pursuing at a graduate level degree. That's one thing I actually find very appealing about NYU's graduate program in mathematics. They foster a great research program in the intersection of algebraic geometry and number theory. What interests me most, however, is their research in the existence and distribution of rational points and curves on higher dimensional varieties. Also, another appealing part about NYU to me is the collaboration they foster between graduate students and faculty members at neighboring universities such as Columbia by hosting things like graduate student seminars. Also, being a resident of a small town like Logan, Utah, I definitely wouldn't mind the experience of living in a big city such as New York. Over the past couple years, Utah State has given me the opportunity to engage in undergraduate research in mathematics. Obviously, this has greatly strengthened my abilities to conduct mathematical research. But I think the most important thing is that this has developed my passion for mathematics. This has given me the drive and persistence necessary to succeed as a professional mathematician. Also, Utah State has given me the opportunity to teach undergraduates mathematics in the form of recitations. This has greatly strengthened my ability to present mathematical ideas to others. And I think that these qualities are what make me such an excellent candidate for NYU's graduate program in mathematics.